Namaskar, good evening, and welcome to today's NAST webinar organized by National Anveshika Network of India, NANI, a proud unit of Indian Association of Physics Teachers, IAPT, and Shiksha Sabha. This is Vimal Kumar, and I'm thrilled to guide you through this enlightening session. As we gather here today, let us pay our respect to the presence of legendary Professor H.C. Verma, whose contribution to physics education have been nothing short of revolutionary. His work has illuminated countless minds, inspiring them to delve deeper into the mysteries of science. A proverb that ability captures his spirit is knowledge is power, information is liberating, education is the premise of progress in every society, in every family. Professor Harish Chandra Verma, often hailed as the master of physics, is a luminary in the world of physics education. With a PhD in nuclear physics, he served as a distinguished professor at the Indian Institute of Technology, Kanpur. His seminal textbooks, Concept of Physics, have become an indispensable resource for students nationwide preparing for competitive exams and igniting a passion for physics. His relentless dedication to teaching and his innovative approach have made him a beloved figure in the academic community. Describing Professor H.C. Verma's contributions in akin to सूरज को दिया दिखाना के बराबर है. Trying to illuminate the sun with a lamp. His work speaks volumes on its own. Now let's dive into the main event of the day. We are ecstatic to invite you to the NAST 2024 webinar on computational science in Pingala Chhanda Shastra, presented by none other than Professor H.C. Verma himself. This captivating webinar offering you a unique opportunity to explore the mesmerizing interaction of computational science and ancient Indian poetry. We have allocated 45-minute approx for Professor H.C. Verma sir's enlightening presentation, followed by a dynamic 25-minute Q&A session. So grab your pen and paper and for note-taking and get ready to engage actively. Your participation and insightful questions are highly encouraged as they are enrich the discussion and contribute to an unparalleled learning experience. Let's seize this extraordinary opportunity to learn from one of the greatest minds in physics education. Thank you for joining us. Let the adventures begin. Welcome, sir.
Thank you, Vimalji. It's a great pleasure to be in this webinar, Saturday webinar. I think this is the second last one. And today's topic that I have chosen is the computational science in ancient Indian mathematics. And actually, every Indian should be very proud of our great heritage in mathematics, because our contribution of zero and decimal system is not only something to just be proud of, but it's for the whole world. It is a great gift, because all this engineering, all this medical, and all those progresses that we see were possible only because of the mathematics, and especially the decimal system. The mathematics in Europe was done with those Roman numerals, capital I for 1, double I for 2, triple I for 3, and then I capital V for 4, and so on. But any kind of simple calculation to say something like multiplication of 12 with 14, if you drew entirely in a Roman system without converting to decimal system, it will be some 2 pages long calculation of to arrive that result. So only because of this decimal system in zero, the mathematics became handy And then Europe picked up, and all that industrial revolution and everything started after they adopted our system. So every Indian should be proud of this great gift that our ancestors have given to the world. And just a small glimpse in today's lecture, where we say that this Pingala, who is writing a book or developing some methods to characterize all those verses, Sanskrit verses in different texts, ancient texts, and classifying them based on certain parameters. And he develops so much of mathematics there, not mathematics, the computational science, how to compute things. Today, we are always we are striving for smart, efficient coding and other things, so that a desired calculations can be made in a smaller time, saving the computer time, the disk space, and all those things in least possible number of steps, and so on and so forth. These are the basic parameters for computational science, writing algorithms. But all those things were there at that particular time in Pingala's thing. So let me start sharing and showing you what I have written. So if I'm allowed, let me try. Yeah, so I'm trying to share my screen. And okay, so where I am. Okay, so my first slide says that Hamara Ganit jo Hamara nahi hua. It's our mathematics, and ultimately we could not retain it with ourselves. So that is Hamara Ganit jo Hamara nahi hua. Now this is a simple question, or not question. Let me do a statement. Today I buy this 1000 santare and 100 santare I have eaten. So how would you like to react on this? Today I purchased 1000 santare. Santare is oranges, and then I have already eaten 100 santare. So if I claim that I have done it today, how do you react on it? Anyone? Are they allowed to unmute and answer? Are they allowed to unmute and answer?
Sir, may I answer?
Okay. So the statement I am making is that today I purchased 1000 oranges from market, and I have already eaten 100 oranges. So that's the statement I am making. How would you react on this?
Sir, may I answer?
Yeah, sure.
Sir, it's not practically possible.
It's not practical possible. Okay, fine. What is your name? What
Sir,
is your
Kanishka.
Oh, Kanishka. All right. So Kanishka says that it is not practically possible, but indeed it is practically possible. So can someone tell how it is practically possible?
Sir, may I say?
Yeah.
It may take 50 days or 1 month. No problem.
Okay.
Time doesn't really.
Okay. All right. So let me go to my next slide, and okay. Let me give you a hint. And the remaining 100 oranges I will eat tomorrow. So I have purchased 1000 oranges today. 100 oranges I have already eaten today, and the remaining 100 oranges I will eat tomorrow. Is that possible?
So can I answer?
Yeah, sure.
Sir, I bought oranges for 1000 rupees, and today I ate oranges for 100 rupees, and
Okay.
tomorrow I will eat oranges for 900 rupees.
Okay, good, very good, good imagination. But the thing I am trying to reach is something else, and that is binary number system. You know binary number system? where
Yes,
you
sir.
have only two numerals,
Yes.
0 and 1. Okay. So if you look at that 1,000,000, if you look at that 1,000,000 thing, that will amount to in decimal 8. Okay, because the 3 zeros on the right do not have any value, 0, 0, 0, and that 1 which appears at the leftmost place, that will be the place of 8. The rightmost is 1, then the next left is 2, next left is 4, and next left is 8. Just like in decimal system we have 1, 10, 100, 1,000, 10,000. In binary system the place values are 1, 2, 4, 8. At the place of 1, 2, and 4 you have 0, 0, 0, and that 1 now becomes 8. So I have purchased only 8 oranges, and 100 is 4. The 2 zeros will give you 0, 0, and that 1 will be place value 4. So 4 I have eaten today, and the remaining 4 I will eat tomorrow. All right. Now the thing which I'm going to present about this binary system, I will not reach binary number system, but there's a good course on this ancient Indian science, mathematics, given by Dr. M.D. Srinivas of IIT Bombay, and it is available in NPTEL lectures. So if you go and look for M.D. Srinivas NPTEL, you will, anyone can find that course, and you can open and see the lectures. So it is based on this M.D. Srinivas lectures in NPTEL from IIT Bombay. And then there's a research article by this Nutan in Journal of Indian Philosophy, and volume number, etc. are given. Based on these, I have prepared today's talk. All right. Now this binary system is normally it is told that Leibniz developed this binary number system in the year some 1695. But the Pingala, Maharshi Pingala, who was our ancient, I don't know what to say, musicologist, or he had developed this binary number system to interpret all that musicology in Indian scriptures and texts, some 3-4 centuries BC perhaps. So much more than 2,000 years ago. This Leibniz thing is only 300 or 320 years ago. So it is that Pingala who does it. Now, Pingala has written a book, Chhanda Shastra, in which this binary system and many other things which involves a lot of computation and algorithms is there. So the basic topic of this Pingala's Chhanda Shastra is classifying metrical pattern. So if you have any verse or any poem, then all these words there or all these letters there, they come with some syllables. We call them syllables. And syllables are two kinds, short and long. I'll just tell, but in our tradition, Vedic tradition, that purity of pronunciation was very, very important, and therefore the timing and how much time is to be given to each letter or half letter. So those things were very, very critical in our tradition, and therefore this classification of those shlokas was also important, and Pingala takes that thing. The book has some 310 equations in 8 parts. A lot of commentaries are there, so those things are there, fine. It has been translated in German in 1863, and if you want to have a first-hand reading, it is also available at Amazon, Chhanda Shastram. Okay, and blah blah blah. So let us talk of syllable. So syllables means how long you are pronouncing that particular letter. So there are 2 varieties. One we call short, one we call long. Long is with long vowels. Long vowels means just like we say ki and ki, jabki, uski. So that ki, you have 2 varieties of ki. One is, or in English, if you write ti, then you will just Swati. You will just Swati. Look at T. How much time you are spending in pronouncing T, Swati. But then if it is T double E, then that T will be much longer. So similarly, you have many of these, this U also, U and W. P-U-T, you say put. So poo is very small. But if you have B-O-O-T, boot, the boo is longer. So this is longer syllable. And put, poo is shorter syllable. But boo is longer syllable. So similarly, you have short and long, short and long. And the rule is longer syllable we say when that consonant is coming with that longer vowel. Longer vowel means like double O, like double E, that longer vowel. And then consonant with smaller vowels is also okay, provided that is also called longer syllable, provided just after that this letter is composite letter, just half and one and a half, like say school. So S is half, and then school, ko is ku. So that if there is a consonant with shorter vowel, but the next one is a composite letter, then also it is taken as the longer syllable. And the one which is not longer is your shorter syllable. Now this, for example, here is an example. This is a line, let us say, Buddhihin tanu janke. It is from Hanuman Chalisa. Or Buddhihin bu. It is shorter syllable, bu. Dhi. It is shorter syllable, bu. It's a small u. But then since the next one is composite letter, half the and then the, buddhi. The and the is composite. So this smaller u, smaller vowel bu also will be taken as a longer syllable according to the rule. Then dhi is buddhi. So that buddhi, it is a small, shorter e. So that will be your shorter syllable. Then hina. So he will be longer. Na will be shorter. Na will be shorter, but if it is na, that will become longer. So like that. Then tanu, ta is shorter because it ends with a, not a. A will be longer and a will be shorter. So ta is shorter. Nu, tanu. So it is shorter. Jan, ja will be longer. No will be shorter. K will be shorter. So if you write this, all those longer syllable, you write G, and then great, you can say great. And this smaller syllable, you write L. Then this sequence that is on the screen, and that sequence, which is this sequence. This sequence. This is G, then L, then G, then L, then L, then L, then G, then L, then L. It becomes this. So there are 9 syllables here, n is equal to 9. And similarly, you can do. Now, if you wish, we can you can try something else. Let us take the next line. Bal buddhi vidya dehu mohi. So you can write the sequences of which is short, which is long, and you will end up with some sequence of G and L, G, L, L, G, whatever. So each verse or each half verse corresponds to a particular symbol, a particular sequence of 2 symbols, G and L. All right. So this, if you wish, you can do it now or you can do it later. So the Pingala's task in that Chhanda Shastra is to classify these verses based on the patterns of this G and L. Okay. So for that, he has developed a lot of things. So first thing he has developed in this book, not first, maybe somewhere in between, is this matrix, this prastar we write for matrix. So in that Chhanda Shastra, he talks of a kind of matrix. Of course, the name matrix will not be used, definitely, but he makes this, he takes this idea of matrix and arranges in rows and columns. Okay, so your all these in horizontal row, you write this GL, GL, LL, LG, and then the second row will, for second line, it will be written below that, third line, it will be written below that, and so on. So that is how the matrix is made. Now, how do you make matrices? In that example, I had taken the Buddhi in Tanu Janage, in that there were 9 syllables, some G's and some L's. So depending on that N, how many syllables are there, how many combinations are possible? Okay, suppose I have just N is equal to 3. Let us say just 3 syllables. So N is equal to 3. So if N is equal to 3, you can have G, L, L, or G, G, L, or L, L, G. Like that, how many of such combinations you can make with N is equal to 3? Tell me. 3 combinations I have written on the screen. Are there other combinations possible?
9. 9, sir.
6.
6, 9. Okay.
So in total 8.
To 8. So if it is 3, you can perhaps guess whether it is 6 or whether it is 8 or whether it is 9. But if it is, say, 10 syllable, then this could be difficult. So the first thing he is doing is he wants to write all the possible combinations. Once I know how many syllables are there, not only that, how many different combinations are possible, what are those combinations? Correctly writing all those different combinations in a matrix form, that was the task, so that he can classify. If the text has, let us say, 500 verses, then each verse correspond to this one of these things. Suppose it is all it's music, so it is all written with the all the verses are of same size, and there are, let's say, 10 or 9 or 14 or 13 or 12 or 8 syllable in each verse. So the classification is, first he will write all the possible combinations of these GL sequence, all the possible sequences he will make. And then if there are 500 or 1000 shlokas in that particular book or particular construction, then he will classify which verse correspond to which sequence. So based on that, he will do all that musicology. So here is an algorithm. How to write different sequences. How to write different sequences for given N. What is N here? N means number of syllable in one sequence. Number of syllable in one sequence, which is fixed. Depending on how the author has written, how long are those verses. So that N is fixed. But once that N is given to you, N is equal to 7 or N is equal to 12, you have to write all the possible combinations of those G's and L and G's and L. So what is the method? Pingala has devised this method. He says that if you know the matrix for N, you can write the matrix for N plus 1 following this scheme. And what is this scheme? It says that if you know the matrix for N, you write the matrix. Then you copy Control C and make Control V. Just below that matrix, you copy that same matrix again and you write. So you write that. Then, since it is now N plus 1, so one more symbol will be needed. So if this is your original matrix, and then you copy it here, then the first half you write all G, 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 and the second half you write all L, 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 and you will get the matrix for N is equal to 1. So method of induction. If you know about N, you can write it for N plus 1. So you can start with n equal to 1 and follow this procedure. So this is the kind of computational algorithm that he is writing, strategy, computational strategy. And remember, Pingala means something like 2000 or 2200 years ago. So if it is just n is equal to 1, so in each sequence, there has to be only one symbol, either G or L. So this is just two possibility. So this is the matrix. This is the matrix for n is equal to 1. Now, how do I write it for n equal to 2? If there are two of them, then according to Pingala's scheme, what you have to do is you have to copy this thing below it. So I'm doing it here. This was it. This was the matrix for n is equal to 1. I copy it below, so it becomes this thing. Then the upper half I write GG, and lower half I write LL, and this becomes the matrix for n is equal to 2. Now check. We have 4 of them: GG, LG, GL, LL. Any other sequence possible with two syllables in one row?
No, sir.
Yeah, so we have written the right matrix from n is equal to 1 matrix. We have constructed n is equal to 2 matrix. So that is the kind of a code that he is telling to construct. Now with this, from n equal to 2, you can go to n equal to 3. You can do it at in your notebook itself. And here is the matrix. I am just putting the box around. This is the matrix for n is equal to 2 that we have obtained from n equal to 1. And then the same story, copy it here, copy it below, and upper half you write G, 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 and lower half you write L, L, L. And you get all the possible 8 sequences which are there. Okay, so that's the kind of computation we were comfortable, very, very comfortable with that, even before all kinds of modern mathematics and modern science. And similarly, you can go ahead from for n equal to 3, you can construct n equal to 4. From n equal to 4, you can construct n equal to 5, and so on. Okay, so that is, and then the gives yet another rule which I am not describing because I am only given 45. Here is that other algorithm for writing that matrix, which I am just skipping. You can write to me if you are interested. Okay, I can share this this PPT also. Now it's your task. You can do it for n is equal to 4 because we already have the matrix for n is equal to 3. So use the same algorithm. You copy this n equal to 3 matrix below itself. Upper half you add another column G, 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 and lower half you add L, 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 L. Now, I asked you the question in the beginning, if there are 3 syllables, how many possible sequences are there? And the answers were 6, 8, 9, etc. It is 8 actually. It is 2 to the power n. It is 2 to the power n. So if you have n places where you can write G and L. Suppose you have n places. Your row has n places. So you have to write sequence of 8 or n syllable. So for the first one, there are 2 possibilities. Either you write G or you write L. Once you have written this either G or L, for the second you have another 2 possibilities, G or L. So that will make 2 and 2 4 possibilities. If for each of these 4 possibilities, you have 2 possibilities here, G or L. So 4 into 2, 8. So similarly, 16 and then 32 and so on. So if there are n elements in the row and you are asked in how many ways you can permute them, it will be 2 to the power n. Now, how to construct, how to know that number 2 to the power n? Okay, so for that, Pingala also develops a particular algorithm because it's computation. If n is large, you cannot do this multiply every time and so on. So he has developed this very efficient algorithm, very efficient algorithm, and for hundreds of years, centuries, this algorithm was used. Not only 100, I believe thousands of years, this particular algorithm developed by Pingala was used in India. How to calculate this 2 to the power n. And I'll just give you a glimpse. I don't know if you have done this kind of flow chart. This is called flow chart. When the first course on computer programming was given to us way back in 1970s, the professor at IIT Kanpur, the first thing he taught us was making flow charts. So it's like that. So the process for finding 2 to the power n has 2 parts. The first part is, so there are 2 parts. The first part is, for a given n, you construct a sequence which I am calling m, and then from n we get this 2 to the power n. So Pingala describes each of them in great detail. Of course, not Pingala. Pingala describes it very cryptically, but then other commentators later expand on that and give more detailed description. So we know it now from those commentaries. So if n is given, the ultimate goal is to find how much is 2 to the power n, and shortest possible time I should get the answer. That's the meaning of efficient algorithm. Of course, you can always do 2 into 2 into 2 into 2 into 2 n times and get it. But then computational time, it has to be done by a machine, then the computational time should be short. So the 2 parts was first to construct a particular sequence m, and then from that sequence m or that number n, the second part tells how to get this 2 to the power n. So this particular picture you are here is to get that sequence m. From the number n, get this sequence m. And what does it say? You start with n, whatever is given to you, and see if it is divisible by 2. This first block here, this block is divisible to yes or no. So this kind of decision making, yes or no, it's all there. Today also we have, in any computer language, the 2 things are very important. One is this branching. There's a question. If it is yes, go through this route. If it is no, go through the other route. And other is looping. Do it again and again and again and again. So look here, this is that branching thing. Divisible by 2 is this n, small n, divisible by 2. If the answer is yes, you go through this left side, this side. If it is no, go through this side. Okay, and if it is yes and come here, then you see if it is divisible by 2, then on the right hand side, if it is 2, then divide that n by 2 and make new n. N is replaced by n by 2. All these things we learn in modern computational programming. At least I had done this way only. So replace n by 2, and then go back, this arrow here, this arrow, go back here and again ask that question. And if it is again yes, then again go through that left branch. And if it is not divisible by 2 at any stage, then you go through this right branch. And then if you, in this m sequence, if this you have on the right side 0, on the right side 0, then n should be replaced by n minus 1. And then again a question is asked, is n equal to 0? If yes, then stop, you are done. Otherwise you go back and do the entire thing. So I can give you this slide, and then you can construct m from n. Okay, all right. And so this is your task, and I have said that do it for n is equal to 14. So from n equal to 14, you get this m. And I have done it here. In fact, I have done that same way that is written, and that m comes out to be 202020. So this is the first part. Remember, we are targeting for 2 to the power n. but this is the first part of it. I get this M. So M is 202020. And from this M, I have to get this 2 to the power n. And for that is the part 2. This is the part 2. And again, Pingala describes what to do. So you start with some number 1 and then look at this M. Look at this M and go from right to left. This is M. In our case, it is 202020. So you start with this, then go here, then go here, then go here, and so on. So look at M and come from the rightmost towards left. If the number is 0, then multiply it by 2. And if the number is 2, then square it. So the instruction is you come from the right. If it is 0, you have to start with a equal to 1, and then this next algorithm goes on. Then you double the number. But if you find 2, you square the number. I'll just show you. And you do it for n is equal to 4, which is m is equal to 202020. This is 14. This is not 4. This is 14. This is 14. Okay. So I start with 1. This is 0. This is 0 here. Rightmost is 0. So I multiply by 2. I have to double it. So I multiply by 2 and I get this. This is my number 2. I go one step left and I see that it is 2. That means I have to square. So this 2 is a square and I get 4. Now my n is this, my number is 4. So then I go one more step here and it is 0. So that 4 is multiplied by 2. And then my number is now 8. And then next one is 2. Here this number is 2. So I have to square. So 8 square is 64. And then I go here. And then it is 64, double it. So it is this. And then again 2. So square it. And that's it. 1, 2, 3, 4, 5, 6. 6 steps I get it. 2 to the power 14. I don't have to multiply by 14 times. 2 into 2 into 2 into 2. I don't have to do it. In 6 steps, I can get this 2 to the power n. Of course, that m has to be constructed. That also takes time. All right. So, and this was such a good and efficient algorithm that in Indian science, Indian mathematics, long time mathematicians have used this algorithm, which was developed by Pingala. Now comes that binary thing. So let me just spend 5 minutes or so. Suppose I have n is equal to 3. Just for demonstration purposes. No verse, no shlok will just have n equal to 3. It will be n equal to 14 is one chosen this number for writing those shlokas and verses. But for demonstration, n is equal to 3. You have these 8 sequences, 8 possible sequences, G, 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 L, G, G, and so on. Now, if you write G equal to 0, 0 in place of G and 1 in place of L, what it becomes? Pingala does it in the Chhanda Shastra book. He replaces this. He writes this G. He writes 0 for G and 1 for L. So G, G, G will be 0, 0, 0. L, G, G will be, L is 1, G is 0. So 1, 0, 0. So 0, 1, 0, 1, 1, 0, and so on. So all these 8 possibilities are now 8 different numbers written in terms of 0 and 1, 0 and 1, 0 and 1. So from there starts for the first time the use of binary numbers, the binary way of writing numbers. So this is this. Then it doesn't stop here. He converts this to the corresponding decimal number. Because if n is equal to 13 or 14 or 8 or 12, it can be a long, long thing and very difficult to classify based on the sequence. So he develops yet another he develops yet another way. This is the algorithm written here, and then some practice sessions are given here. Some examples are given here to get that corresponding decimal number corresponding to this binary sequence of ones and zeros. And then he tells how to do that, how to convert this binary sequence into a decimal number, corresponding decimal number. So you just have a decimal number and you know that, okay, this particular slok, this particular slok, this particular slok, all these correspond to this particular decimal number. So that long sequence of 14 L and G's or zeros and 1, 14 the total places, 0 and 1, such a long, it's very, 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 very untidy. But then if you have some decimal numbers, yes, good. All those decimal numbers you can easily write and remember. So those conversions from binary to decimal and from decimal to binary, that are all described, okay, with certain difference. In modern system, when you write in binary, your sequence here is 1, 1, the place value. The rightmost is 1, then 2, then 4, then 8, then 16, and then 32, and so on. In Pingala system, the place value start from left. The leftmost will be 1, the next one will be 2, the next one will be 4, and so on. So this is one difference with the modern binary system that we are using, and Pingala has developed there. So that is one difference. And another difference is that after putting those place values, an extra +1 is written. So Pingala says that add 1 to get the decimal equivalent. And why that extra 1 is coming, addition of 1 is coming, that also we understand, because in the modern system we start our counting from 0, but Pingala starts his counting with 1. So that is why that extra 1 is coming. But nevertheless, this whole thing that Pingala has developed insight, if there are two possibles, G and L, the shorter syllable and this longer syllable. So there are only two types. It can be written as a sequence of letters first, and then they can be represented by 0 and 1. In textbooks also, where this is gates, etc., you study, you say that your bulb is on, off. So you say that, okay, off is 0, and then on is 1. And then you can do corresponding analysis and you construct OR gate, NOR gate, NOT gate, and so on. So Pingala has all that mathematics ready with it, and so on. So a lot of things are there. And okay, so I think let me stop here. And these are various examples that I had written, that you can do all these calculations yourself, and so on, so on. These are all for calculations, binary, how to convert Pingala's binary into decimal and decimal into binaries, so on, so on. So okay, good. So that is my presentation.
Thank you very much, sir. Now we have a Q&A session.
Yes.
Sorry, can I? Hello.
Yeah.
Yes, yes.
Yeah. So you told that Pingala added 1 in order to synchronize it with starting with 1. So how do we write 0 in binary? Because I don't think we can write 0 in binary.
Is 0 itself is a binary number? No, I didn't get your question. In binary system, modern binary system, we have two numerals, 0 and 1. And if your number is one more, then you write it as 10. In decimal system, we use these from 0 to 9. The 10 symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are one-digit numbers. There are these 10 one-digit numbers are there starting from 0 up to 1. In binary, you have two different symbols, 0 and 1. And if you have a bigger number, you have to go for two-digit numbers or three-digit number or four-digit number. Just like in decimal, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if your number is more than 9, then it will not be represented by one-digit number. it will be represented by at least 2-digit number. 11, 10, 13, 14. This is how we will do. 99. This is how we'll do. If the number is more than 99, then you will have to use 3 digits. In binary systems, there are only 2 symbols. 0 is very much there and it's same as the decimal 0. And 1 is the next digit, the next symbol, and that is very much same as the decimal 1. But then next in binary system, we don't have any more symbols. So we have to go for 2-digit number. The next number will be 1 and then 0. Equivalent to decimal 2. Then the next number will be 1, 1. And that's it. If you want to have bigger number, you have to go for 3 digits. 100 will be the smallest one. Then 101, 110, 111. Exhausted. Then you go for the 4-digit number and so on. Okay?
Understood, sir. Thank you.
Yeah.
Sir, may I ask a question?
Yeah, sure.
Sir, what do you think that Pingala was calculating by with the help of this matrix?
Pingala had, he was basically interested in metrical arrangements of different poems, right? In Sanskrit Shastras. So in Sanskrit, you have so many Rigved and many things written there. Varieties of scriptures, varieties of Puranas, and all those things are there in poetic form. And in poetic form, you have a structure for each line, each part of that poem. You have a structure, and it has to be matched. So in general, in a particular poem, you will have, say, 200 lines, or 12 lines, or 20 lines, or 50 lines. So each line has a structure, and the letters which are coming, the words which are coming in that line, and then the letters that are coming in that line, they will be pronounced with 2 varieties, that is the shorter and the longer syllable. Okay, you take anything, you say Vande Mataram. Vande Mataram. So ma, you have to put more time. Mataram. Ma, you are putting more time, longer time. Ta, you are putting shorter time. Ra, you are putting shorter time. Mo, you are putting shorter time. So Mataram, it will be long, short, short, short. Right? Vande. Now Vande, again, this wo is short as such, but since the next letter is composite, half no and then the Vande. So this wo will also be taken as longer, but they will be shorter. So Vande will be longer and then shorter. So this whole line is corresponding to a particular sequence of shorter and longer, shorter, longer, 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 less, shorter. So so this is a sequence. Now he wants to systematize all this. Let's say Rig Veda. I don't know how many shlokas are there. Let's say the 1,000 shlokas are there. So he will tell that, okay, out of these 1,000 or 1,200 shlokas, there are 67 corresponding to this particular sequence of shorter and longer, and then there are 37 which are of this type. So he's classifying how many types are there. Okay, so that kind of classification, and then goes across the text. This text. One is Rig Veda, one is the other thing, one is Sam Veda, one is the Garuda, one is Kathopanishad, Upanishad, Puran, etc., etc. So all these things which were there, he wanted to systematically study the structure of this metrical form. So for that, he has developed all this mathematics.
Yes, sir, I understand. Thank you, sir.
Yeah.
Good evening, sir.
Yeah.
Thank you, sir.
I think
Sir,
I can stop the sharing, I believe.
सर जैसे कि हमने देखा स्टार्टिंग में हमारा जो मैथमेटिक्स है वो इतना एडवांस था उस समय, और
हाँ
उसके
जी।
बाद क्या हुआ कि हम जो मॉडर्न मैथमेटिक्स है इसमें हम थोड़ा लैग कर गए वेस्ट से।
जी हाँ, ये आवाज कैसे बंद हो गई?
सर वो क्वेश्चन आई थिंक पूरा हो गया उनका।
नहीं, क्वेश्चन पूरा नहीं हुआ है।
यस, मे आई आस्क अगेन?
या हाँ हाँ, यस, पूछो।
सर जैसे कि वेदों के टाइम पे हमारा जो मैथमेटिक्स था उस समय के बाकी वर्ल्ड के कंपैरिजन में इतना एडवांस था, और उसके बाद क्या हुआ कि हम जो मॉडर्न मैथमेटिक्स है इसमें लैग कर गए, बच्चों से पीछे रह गए हम।
हम्म। हाँ हाँ, तो
सर,
आप या हम, ये तो आप फैक्ट बता रहे हो हमें, मुझसे क्या कमेंट चाह रहे हो?
सर कैसे हुआ ये?
कैसे हुआ? हाँ, तो देखो क्या हुआ ना कि ये बहुत सारी राजनीतिक परिस्थितियां होती है, सामाजिक परिस्थितियां होती हैं, भौगोलिक प्रक्रियाएं होती हैं। अगर कहीं पर बहुत सारे समय तक खूब सारे अर्थक्वेक आते रहे, खूब सारे अर्थक्वेक आते रहे, तो वहाँ का जो डेवलपमेंट है वो रुक जाता है, जो साइंटिफिक डेवलपमेंट है वो रुक जाता है, इकोनॉमिक डेवलपमेंट है वो रुक जाता है। इसी तरह से किसी देश को खूब सारी लड़ाइयाँ लड़ने पड़े, खूब सारे उसके ऊपर हमले हो जाएं और होते रहें होते रहें होते रहें, दूसरे लोग हमें हमारे ऊपर विजय प्राप्त करके और हमारे ऊपर शासन करना शुरू कर दें, अत्याचार करना शुरू कर दें, तो फिर हमारे जो साइंटिफिक प्रोग्रेस है, मैथमेटिक्स की प्रोग्रेस है, सब चीज़ों की प्रोग्रेस है, लिटरेचर की, आर्ट की प्रोग्रेस है, वो रुक जाती है, वो आगे नहीं बढ़ती है। तो बहुत सारे फैक्टर्स इस तरीके के होते हैं हिस्ट्री के अंदर में, जहां पर कि कभी राइज होता है, कभी फॉल होता है। तो अपने साथ भी ऐसा ही हुआ। ये जो मॉडर्न मैथमेटिक्स यूरोप के अंदर में ज्यादातर जो डेवलप हुआ है, उसका बेस हमारा मैथमेटिक्स है। जो हमने यहाँ डेवलप किया है मैथमेटिक्स, वो बेस वही है। वो अरब कंट्रीज से अपना थोड़ा आना जाना ज्यादा था, तो वहाँ के लोगों ने हमारे सिस्टम को देखा और उनको पाया कि ये मैथमेटिक्स तो बहुत स्ट्रांग है, तो वो लेकर के गए हमारा मैथमेटिक्स, उन्होंने उसको वहाँ अरबी में अनुवाद किया और वहाँ अपने यहाँ उसको पढ़ाया, अपने यहाँ लोगों को सिखाया कि ऐसा मैथमेटिक्स कितना बढ़िया है। एंड वहां से चूंकि यूरोप का कनेक्शन बाद में बना, तो यूरोप के लोगों को वहां से पता चला कि अच्छा, ये मैथमेटिक्स ये भी होता है, तो उन्होंने उसको अपनाया। तो अब उनकी तो राजनीतिक सामाजिक परिस्थितियां अलग थी, तो उनको जब मैथमेटिक्स का टूल मिल गया, तो बड़ी तेजी से उन्होंने प्रगति की और अपना और मैथमेटिक्स का डेवलप किया और साइंस डेवलप किया, इंजीनियरिंग डेवलप की। हमारे यहाँ जो था वो हमने अपने टाइम में, जिस समय हमारी सामाजिक राजनीतिक परिस्थितियां अच्छी थी, उस समय में हमने भी मैथमेटिक्स का बहुत विकास किया, और केवल मैथमेटिक्स का नहीं, उस पर बेस्ड इंजीनियरिंग का बहुत विकास किया। उस समय के हमारे जो बनाए हुए आर्किटेक्चर हैं, हमारे जो बिल्डिंग्स हैं उस समय के, जो जो एक्सकेवेशंस में से निकले हैं, जो खुदाइयाँ आर्कियोलॉजी डिपार्टमेंट वाले करते हैं, उसमें से जो चीजें निकली हैं, वो किस तरीके से सिस्टमेटाइज्ड हैं बिल्कुल। तो हमने अपने मैथमेटिक्स का उपयोग भी किया है वहाँ पे। मेटलर्जी के अंदर में हम लोगों ने बहुत प्रगति की, हमने वो मेटल्स को मेल्ट करना सीखा, मेटल्स को मेल्ट करके अलॉयज बनाना सीखा, और हमारे यहाँ बड़ी बड़ी उसकी फैक्ट्रियां उस समय में 3,000 साल पुरानी, 2,000 साल पुरानी, वो सब खुदाई के अंदर में निकल रही हैं। तो हमारे यहाँ भी बहुत ज्यादा न केवल साइंस का और मैथमेटिक्स का विकास हुआ, हमने इंजीनियरिंग का भी बहुत विकास किया। हमने ओशन का बहुत विकास किया, जो ओशन की इंजीनियरिंग है, जो उसके अंदर में नेविगेशन है, हम बाहर बाहर जा करके अपना सामान बेचा करते थे, तो वो समुद्र के अंदर में नावें कैसे चलेंगी, उसके लिए तो बहुत इंजीनियरिंग लगती है, वो सब हमने किया। लेकिन फिर वो हमारी ही चीजें लेकर के उधर के लोग जो है वो आगे बढ़े, और हम फंस गए कई तरीके के राजनीतिक उथल पुथल के अंदर में। हमारे ऊपर बहुत सारे आक्रमण हुए, जिन्होंने आक्रमण किए उन्होंने हमारे यहाँ बहुत तबाहियां मचाई, हमारे सारे इंस्टीट्यूशन जला दिए। जितना हमारा नालंदा विश्वविद्यालय में इतनी बड़ी लाइब्रेरी थी, कहते हैं कि महीनों तक जलती रही वो, उसको जला।
There was a case about Takshila University also.
तक्षशिला यूनिवर्सिटी। तो ये सब लेकर के, और हम अपने सर्वाइवल में इतना उलझ गए, अपने सर्वाइवल में इतना उलझ गए कि हमारा सारा चीज जो है सो रह गया। और हमारी चीजों में उस समय में ये कम्युनिकेशन का जो हमारा था कि डॉक्यूमेंटेशन होना चाहिए, प्रिंटिंग होनी चाहिए, प्रिजर्व करके रखना चाहिए, वो हम नहीं कर पाए. सो अभी हमारे पास में गिने चुने चीजें अवेलेबल है. पिंगला इज वन ऑफ देम. गिनी
Can
चीजें,
I add
गिनी,
one more point to it?
या
Sir, like she asked the question, and my answer to it is that the modern techniques that are coming in other countries, जो अभी recent में countries में आ रही है, वो already हमारी countries में वास्तुज and devas में already invent हो चुकी है. Like you gave the example of Pingla. So you already gave this example. So I think the modern techniques that are coming right now in the evolution of other countries are already there in our Vasudevas and all. Like in Hanuman Chalisa, the distance of sun, not a proxy, it is already mentioned. So I think it is already there in our country.
नहीं, मैं उस पे नहीं जाऊंगा. मैं उस पे नहीं जाऊंगा और मैं इस पे ज्यादा वो enthusiasm के साथ I will not comment on it, because people in Western countries, they have done it with much more mathematics. For example, you say gravitation, right? So it's okay. Bhaskaracharya has written in his book that Earth attracts everything towards its center, and Bhaskaracharya is at least 500 years earlier, senior than Newton. That's fine. But the way Newton has described it quantitatively, 1 by r square dependence, Bhaskaracharya has not done that. So we will not undermine the inventions which are being done or which had been done by these Western countries. We will not undermine that. They have done a great job. They have innovated things. They have formulated things. They have discovered things. And in our cases, some mention maybe, but that kind of systematic study was not there. So to say that whatever is being invented in modern science and technology, we already had it at some stage, is perhaps not a scholarly statement. But we are very proud of what we were, what we are, and the way we are handling things. We are very proud of that. We are very proud of that. The findings of archaeology department, which gives us the actual evidence of town planning, and then metallurgy, and then water conservation, the waste management. Wonderful things are coming, which are there in our history. We are very, very proud of it, and we must propagate those things, that yes, we had such an advanced technology at in those 3,000 years ago, or 5,000 years ago, or 7,000 years ago. But at the same time, we should refrain from making statements like this, that whatever is being discovered or has been discovered by others, it was already there in our culture or in our text. That I think that we should avoid that.
So every discovery in science is a step towards entire mankind's future. So
Correct,
like
correct,
every discovery should be credited equally.
correct. But unfortunately, the discoveries that we made thousands of years ago, they are not being honored. They are not being honored. You say that they should be honored equally.
Yes, so that's a problem. They're not being honored.
Yes. So we are the victims. So our people should know it very well. Right?
Sir,
Okay.
may I ask a
Excuse
question?
me, sir.
Yeah.
Hello. So good evening, sir. So my name is Natik Thakur. So I have a doubt.
Yeah, please.
So you said that the Pingala binary number system. So sir, I want to ask this: if there is any restriction to use them?
Any?
Restrictions to use them?
No, why should we? See, the entire essence is there. What we are saying, that to conceive the idea of binary numbers, to conceive the idea, and then to develop mathematics, how to connect the decimal system to the binary system, that we had done. Now, it's not that the left to right is superior than right to left or inferior. The whole thing is that this idea was not conceived for the first time by Leibniz. This idea was conceived by Pingala 2,000 years ago, not in the 17th century. But then we need not use that Pingala's word by word algorithm. Algorithm was very good. That 2 to the power n algorithm is still very good. I very much like it. But then saying that, okay, since Pingala has done it left to right, the leftmost is 1, then 2, and then 4. So why don't we use our Pingala system instead of going right to left as it is done in the decimal system, or it is done in modern binary systems? That doesn't make much sense. So it's good if that is in use, left to right, fine, no problem.
Sir,
And
may
sir,
I
I
ask the
have one more.
question?
Good evening, sir.
Good evening.
Sir, I'm
Sir,
Akshat Mehta, studying in 9th grade in the Navy Children's School.
Okay.
Sir, I have always seen my brother studying from your books, and I'm so grateful to talk to you.
So nice of you. Thank you.
Sir,
Well,
my question is that how can we as students do to take our country to the next level?
you study your textbooks and your whatever is in your syllabus with a much deeper investigative eyes. Okay.
Yes, sir.
You go deeper into it, find anomalies, find gaps, find the possible extensions instead of just knowing what is written there and understanding what is there in the book. So if you go with that kind of vision, that kind of purpose, that I am studying it, but I always have this question marks every time. So if you develop your skills that way, yes, you will be doing a great service to the nation.
And sir,
Good evening,
what
sir.
career path should we choose to the in our future?
Whatever gives you satisfaction, whatever gives you pleasure.
To take our country to the next level?
Yeah. There are 1,000 ways to do that, and every person will have his or her own style of possibility. Okay, so it's not. That's why I said whatever gives you pleasure, you master that. You develop your skill in that area, and then you excel in that, and that will be the service to the nation. Right?
Okay, sir.
Sir, I'd like to ask a
Sir.
simple question.
Good evening, sir.
Good evening.
Sir, I'm really honored to talking to you. I'm also a student of your books.
Thank you.
Sir, my question is that according to this Pingala's mathematical computations, can we Indians are able to describe the quantum computations, which is are ongoing by the IBM or Google?
I don't have any such. I have not encountered any such thing. Philosophically, we have thought many things.
Yes, sir.
But that was in the thought
सर क्या
process.
मेरी बात हो सकती है सर से? क्या मैं बात कर सकता हूं?
Okay, let me just finish this answering. So at the philosophical level, we have thought of many things like the oscillating universes and many universes and other things which are now coming with quantum cosmology, at least quantum computing. I am afraid that there was any development in. At least we don't have any evidence for that.
According to Sir Pingala's mathematical computation, there are possibilities of many possibilities. In binary system, there are 2 possibilities: yes or no, on and off, like that. But according to my opinion, in Pingala's mathematical computation, there are more possibilities rather than binaries. So, is there any possibility to connect this binary?
Hello, sir. Sir, I am leaving this group. Bye, sir.
Okay.
Pingala's computationals to quantum computational. So this my.
Okay, if you go into it and you find something, please write to me also, because I do not have any such information that quantum computation can be connected through Pingala.
This is my thought. This is my thought.
You try to research on it. You try to research in it. If you find something positive, then let me know.
Sir, good evening, sir. Good evening, sir.
Good evening.
Sir, this is Sarvajit Murali from Chennai, sir. I'm a very
Okay.
big admirer of you and how easily you teach us physics concept. I find it very easy to learn, sir.
Oh, so nice.
Currently pursuing in class 12. It's very happy to
Okay.
meet you, sir. So
Oh,
my
thank.
question to you is, what are some good areas of research in physics and mathematics in the future, sir? Because I'm really interested in this area.
So I think you should choose this pure science, physics, or mathematics, or if you like that, and you go to some good institutions. IITs also teach physics and mathematics separately. They give master's degree, BS degree, and master's degree, and then explore. Because once you go to a good institution, you interact with many people. You look at the work done by different groups, and then you will be better placed to select your area. The areas are not good or bad. It is suitable for some person and not suitable for some other person. So if you have an exposure to n different aspects, then you will know to, okay, I am made for it. So my suggestion is that at this moment you focus on your 12, do well, and then for the bachelors you go for a good institute. ICERs are there, IITs are there, or many central universities are there, and there if you are able to look at different areas in which people are doing. For example, if you are in IIT Kanpur, you will be able to interact with people who are doing this space technology. If I'm talking of physics, not engineering. And then there are people who are going into the condensed matter, solid matters, how solids behave, and how we can make smart materials, new materials with different kind of properties which can be used in different technologies. And then there will be people who will do who are working for aviations, people who are working for all kinds of magnetisms, and many such areas are there. Low temperatures, so many areas are there. So at this moment you won't be able to find the essences of all these areas, and therefore deciding or even trying to decide at this stage, I think that is not advisable. So you go to some good institution where pure science is being taught, ICERs, IITs, or
हेलो, मैं क्या बात कर सकता हूँ? क्वेश्चन पूछ
and
सकता हूँ?
okay, बस तुरंत 2 सेकंड और दे दो. And then Sarvajit, then you in your first year or in your second year, first year anyway is normally common courses for everyone, and there you want to interact with people, groups, research groups, doing things, and then you decide on that.
Yes, sir. Thank you very much, sir.
हाँ, बताइए, आप बात करना चाहते थे, बोलिए.
हेलो,
हाँ जी.
गुड इवनिंग सर, मैं डॉक्टर अभिनय कुमार शर्मा
जी
प्रयागराज
बताएं.
से. सर मैं
Yes.
ये जानना चाहता हूँ, जो आप अभी पिंगला में बाइनरी नंबर सिस्टम के बारे में बता रहे थे, और
जी.
उसमें मैं चूंकि कम्युनिकेशन पढ़ाता हूँ, तो
जी.
मैंने एक चीज देखा, जब कम्युनिकेशन में कोई कम्युनिकेशन कोई सिग्नल ट्रांसमिट करते हैं, तो
जी.
उसमें 1 बिट एक्स्ट्रा देते हैं. तो मुझे आज ऐसा लगा कि जो 1 बिट हम जिसको हम बोल रहे थे कि जो एक डिस्टॉर्शन या एक्स्ट्रा सिग्नल दे रहे हैं, तो मेरी समझ में इंडियन मैथमेटिकल के हिसाब से, चूंकि हम 0 को काउंट नहीं कर रहे हैं, 1 को काउंट कर रहे हैं,
जी.
तो
जी. जी.
मुझे लग रहा है कि वो 1 जो है, जो हमको सिग्नल डिकोड कर रहे हैं,
जी.
वहां
जी.
पे हमें वो जो सिग्नल मिल रहा है वो ओरिजिनल सिग्नल मिल रहा है.
ओके. ओके.
तो
ओके.
आई थिंक दैट दिस इज राइट और नॉट.
आप छंद शास्त्र की किताब ले लीजिए, थोड़ा सा उसको पढ़िए, और आपकी एक्सपर्टाइज चूंकि अभी मॉडर्न कम्युनिकेशन सिस्टम में है, तो यू विल बी मच बेटर इन ए मच बेटर पोजीशन. और आप उनके लिंक्स देखिए कि किससे क्या कनेक्ट हो रहा है और किससे क्या निकलता है. यू प्रिपेयर योर ओन टॉक एंड सम काइंड ऑफ आर्टिकल, और फिर आप भी हमें बताइए, सभी लोगों को बताइए कि ऐसा ऐसा है.
सर एक चीज और जानना चाहता हूँ कि मैं जैसे मैथमेटिक्स फिजिक्स पढ़ाता हूँ, और मेरे
जी.
साथ एक बहुत बड़ी प्रॉब्लम ये आ रही है सर, कि एक्चुअली में सर मैंने जो फिजिक्स में जो प्रॉब्लम देखी कि सर जो मॉडर्न फिजिक्स पढ़ाने का जो आइडिया है और जहां पर फिजिक्स आके रुक सी गई है, उसका कारण ये है कि लोग फिजिक्स में मैथमेटिक्स ज्यादा पढ़ा रहे हैं इन देयर की उस प्लेस पर कि जहां पर फिजिक्स में थॉट्स डेवलप होना चाहिए कि कोई
जी हाँ।
एटम है वो मूवमेंट कर रहा
हम्म
है, उसमें क्या फोर्स। जैसे मैंने आपकी ढेर सारी किताबें पढ़ी, जैसे मैंने इससे पहले एक लेक्चर सुना था जो जापान से सर ने बताया कि कैसे रिफ्रैक्टिव इंडेक्स के कारण कैसे एटम्स में जो चीजें एक्चुअली में इंटरव्यू में जब हम लोग जाते हैं तो टू दी पॉइंट जो जो
जी
फिजिक्स ना जान करके सबसे बड़ी प्रॉब्लम ये क्रिएट हो रही है। सर जैसे मैं हूँ, मैं बहुत सफर कर रहा हूँ और मैं एक यहाँ इलाहाबाद विश्वविद्यालय में डिपार्टमेंट ऑफ जेके इंस्टीट्यूट से मैं पीएचडी हूँ, लेकिन
जी
सर प्रॉब्लम ये हो रही है सर कि मैं सरवाइव कर रहा हूँ, मैं फिजिक्स जानता हूँ लेकिन वो मैथमेटिक्स नहीं जानता हूँ जो कि वो लिखवाना चाहते हैं। और सर मुझे लगता है कि अगर वो मैथमेटिक्स से हट के जो फिजिक्स है रियल में, जैसे आपने जो कॉन्सेप्ट ऑफ फिजिक्स लिखी तो उसमें आपने अपनी थॉट्स लिखी और
जी
आपने अपना, तो मैं वो लिखना चाहता हूँ, मैं जानना चाहता हूँ, लेकिन सर वो प्लेटफॉर्म नहीं मिल पा रहा है, तो मैं क्या करूँ
अब
सर इसके लिए?
मेल लिखना मुझे फिर बात करेंगे हम।
ठीक है सर, ठीक है सर। बहुत सर हमको बहुत ही सर गर्व महसूस हो रहा है कि आज आपसे मेरी बात हुई। सर आप मेरे आइडियल हैं और बहुत मतलब फिजिक्स अगर रियल में अगर मैं समझता हूँ कि आज मैंने फिजिक्स में सब कुछ पा लिया आपसे बात करके। थैंक यू
थैंक
सर, थैंक यू सर, चरण स्पर्श सर, बहुत बहुत धन्यवाद।
चलिए, ऑल द बेस्ट।
Good evening, sir.
हाँ
Sir, myself, Natik Maheshwari. Sir, I am from class 10th, Polifamily Convent School. सर मुझे एग्जैक्टली ये पूछना है सर, जैसे हम लोग की जो बुक्स के टॉपिक्स है हम लोग उसी को ही, जैसे जो मॉडर्न फिजिक्स है और मॉडर्न मैथमेटिक्स है जो मतलब इस टाइम में हो रहा है, और जो हमारे
So, Natik is muted now, I think. Hello, Natik. Okay, so we will take one last question here.
Sir, could I ask?
Yes, Samaj.
Yeah, so sir, just now we learned about Pingala's algorithm according to the book. Right, so you told it's your favorite algorithm so far, and I like it too. I like it quite well.
Yeah.
But sir, like in today's world of information, we are all about collecting more and more information, right?
Correct.
So it's all about reducing down these algorithms to its finest so that we can perform the same task but with much more efficiency. So sir, would you think it would be a viable option if we switch from binary to something like some code like hexadecimal code, or codes which use more numbers than just 0 or 1?
Yeah, I don't know that people who are in computation, they will be able to tell better. Okay.
Okay, sir.
Yeah.
Sir, can I ask one last question, sir?
Yes, sir.
Sir, my question is, sir, can you hear?
Yeah.
Yes, you can continue.
Sir, my question is, today's students are not much interested in teaching and research field, sir. What is the reason behind it? Because after Subramaniam Chandrasekhar, there is a very huge gap. We won't get any Nobel Award in physics, sir. That's why what the matter behind that.
Yeah, your first part of the question hurts me also. But second part is irrelevant. Whether we get Nobel or not, that is not important. The important thing that our young generation should come forcefully for teaching and for doing research. Okay, why they are not interested in that is that in our school college system we do not challenge their imagination. The kind of text that we teach, the kind of teaching that we provide, the kind of environment that we provide is not challenging their mind. The only challenge we give that score more and more in examination, varieties of examinations. So that will not bring them closer to the education and research and all those things. So that is the basic problem. That is the basic problem in our education in schools and universities. The students should be able to feel the pleasure of learning. and discovering. So that part is missing. That whole education is to pass examination and finally get some good job. Okay, so this if that pleasure of learning is missing from the system, then you won't get. I mean, as exception, you can get scientists, and that is how our country is progressing. It's not that our country is not progressing. Our country is progressing, but not because the system is supporting. Since we have such a huge population, and some people will always be there who will excel whatever be the system is not orienting students towards research and teaching. That is because they are not feeling that pleasure of learning science, learning mathematics, or learning anything, economics or anything, literature, art. So that is the basic problem, and the remedy lies there only. The teachers are they will have to do extra work. First, they should feel the pleasure of science and mathematics, and then they should make students fall in love with this. And then perhaps it may take a long time, but that's the only way I can see. Okay, thank you.
Sir,
Thank you,
sir,
sir.
can I?
No.
Sir,
Now
please.
we are not going to take any question.
Sir, last.
People can
Sir,
write
last.
email to me. Vimalji, you can announce that you can tell them if there are more questions. They can always write mails to me, and hopefully I will reply.
Sir,
Okay.
where can we find your email?
Yeah, here itself.
I'll write in the chat. Okay.
Okay.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir. Thank you for the session.
Okay, thank you very much. Thank you.
So as we draw this incredible session to a close, I want to extend my heartfelt gratitude to each of you for joining us today. It has been an honor to have you all participate in this NAEST 204 webinar organized by the National Anveshika Network of India, NANI, an esteemed initiative of Indian Association of Physics Teachers, IAPT, and Shiksha Supan. Today's journey through the fascinating world of computational science in Pingala Chhanda Shastra, guided by the illustrious Professor H.C. Verma sir, has been nothing short of enlightening. Professor Verma, with his unparalleled expertise and passion for physics and education, has illuminated complex concepts and demonstrated the profound connection between ancient Indian poetry and modern computational methods. Today's presentation was truly opened our minds to a new horizon, showing us how the timeless wisdom of Pingala Chhanda Shastra can be understood and appreciated through contemporary scientific approaches. Your ability to bridge the gap between traditional knowledge and modern science is inspiring, and the testament to your remarkable contribution to the education. I would like to thank Professor H.C. Verma sir for his time and for sharing his profound knowledge with us. Your dedication to making physics accessible and engaging in truly commendable, and continues to inspire countless students and educators. I also want to acknowledge the efforts of the organizing team of NANI, IAPT, and Shiksha Supan for putting together this successful event. Your hard work behind the scenes has made this enriching experience possible. Before we conclude, I want to share an exceptional opportunity that awaits you: the National Anveshika Experimental Skill Test, NAEST 2024. This prestigious platform is designed for students from grades 9 to 12, alongside bachelor's and master programs in science, to showcase their exceptional knowledge and skills in physics. We strongly encourage you to register for NAEST 2024. This program promises to be the rewarding learning experience and a chance to distinguish yourself from your peers. Your active participation and insightful questions today have enriched our discussion, making it a collaborative and interactive experience. I encourage all of you to take insights gained today and explore further. Let this session be a stepping stone to deeper inquiry and learning. Thank you once again for being with us. Let's continue to celebrate and explore the wonders of science and education together. Thank you. Thank you very much.
Sir, can we get the email of sir?
Yes, sir, the email ID.